All right, deep divers, you wanted it, you got it. We're taking a deep dive today into the digits of pi. And guys, get ready. This is going to be anything but a boring math lecture.
That's right. We're going way beyond 3.14 today.
Way beyond. We're talking about a source file we found called, get this, M8AX decimals de pi.txt.
10 million decimal places of pi.
Yeah.
10
It's mind-boggling. And what's even cooler is this source file doesn't just list out the digits, it analyzes them. It actually reveals these, well, patterns in pi.
Fascinating patterns.
Which is kind of crazy, right? I mean,
Yeah.
When most people think of pi, they think random, unpredictable, right?
Exactly. And infinite, of course. But this deep dive, it really digs into the surprising order within that randomness.
So let's talk about those patterns. What kind of patterns are we talking about here?
Well, imagine you're looking at the first 10 million digits of pi. And you want to know, how often does each number, 0 through 9, actually appear?
Okay, I'm imagining it. What am I going to see?
Most people would guess it's pretty random. Like, some digits show up way more than others.
Yeah,
right?
that's what I think. It's random, so totally unpredictable.
Seems logical, right? But, and here's the mind-blowing part. The source reveals that each digit, 0 through 9, occurs with almost the exact same frequency.
No way. Seriously. You're telling me it's like perfectly balanced?
Almost perfectly. Each digit appears about 10% of the time.
Hold on, are you messing with me?
No.
This is pi, the king of chaos. What are the actual numbers? Give me the hard data.
All right, straight from the source. The digit 0 appears 999,440 times, or 9.994% of the total. And get this, the digit 9 appears 1,040 times, or 10% of the total.
Okay, that is way too neat and tidy for something like pi. So how is this even possible? If it's truly random, why this balance?
That's a great question, and it gets to the heart of what makes pi so fascinating. You see, mathematicians have actually proven that pi is what's called irrational.
Irrational, meaning?
It means its decimal representation goes on forever, infinitely, and it never, ever repeats in any predictable pattern.
Right, infinite non-repeating.
Got it. So where does this even distribution come into play?
Well, you'd think with something as seemingly random as pi, you'd see more chaos, more variation in how often the digits pop up.
That makes sense.
But this near-perfect balance, at least in these first 10 million digits, it deepens the mystery of pi. It's remarkable. So it's like this crazy paradox, right? We've got randomness, but then this weird order within the randomness.
Exactly.
It's like pi's whispering secrets in a language we don't quite understand yet.
And speaking of secrets, there's another layer to this.
Oh, there's more. Lay it on me.
Remember how we talked about the source file analyzing the digits? Well, it also looks at something called the sum of digits.
Sum of digits. Okay, now you've piqued my curiosity. What in the mathematical world does that mean?
So imagine taking all the 2's in those 10 million digits and adding them all up.
Okay, I'm adding. I've got a massive number in my head right now.
Then you do the same thing for each digit, 0 through 9. Add them all up. That's the sum of digits.
Interesting. So it's not just how often each digit appears, but also it's like total value within pi.
You got it. And this is where things get really interesting, because it could reveal these hidden relationships between the digits.
Oh, I like where this is going. Give me an example.
For example, the source tells us the sum of the digit 2 is 2,612.
Okay.
And the sum for 7 is 7,449.
Okay. Big numbers, but what do they mean?
Well, on the surface, they might seem random, but remember, we're dealing with this surprisingly even distribution of the digits themselves.
Right. Everything's balanced.
So it begs the question, could there be a connection between that even distribution and these sums?
Whoa. You're blowing my mind right now. Are you saying there could be a pattern hidden within the sums of the digits, too?
We're heading into uncharted territory here. But that's the thing about pi. The more we dig, the more questions pop up. And this whole even distribution thing, what if it's just a quirk of the first 10 million digits?
You mean it doesn't hold up? What if we analyzed 1 billion digits? 1 trillion?
Exactly. Does this pattern hold, or do we start seeing something totally different?
Now that is a question for the ages.
Imagine the computing power you'd need to figure that out.
The mind boggles. But you know, this is reminding me that pi isn't just some abstract math concept. It's like woven into the fabric of, well, everything.
Absolutely. Pi pops up everywhere, from the orbits of planets to, like you said, the very fabric of the universe.
It's kind of awe-inspiring when you think about it. These simple digits, they could unlock, well, who knows what.
It does make you wonder, doesn't it?
What if we're just scratching the surface?
That's the beauty of it, isn't it? Pi's mysteries are endless.
Okay, but before we dive too deep and get lost in the infinite digits of pi, let's back up for a second.
Good idea. Take a breath.
What are the big takeaways here? What's really sticking with you from this deep dive?
For me, it's that unexpected order we found. We started with this massive file, a sequence of numbers that's supposed to be random. Then, bam, we analyze it and see each digit, 0 through 9, appearing almost exactly 10% of the time.
Right. Almost too perfect.
It really messes with your intuition. Randomness should be messy.
Right.
Unpredictable.
Exactly. And just when you think you're starting to wrap your head around that, we layer in the sum of digits.
Like a hidden message within a hidden message.
It's mind-boggling. It makes you think there has to be some deeper connection going on here between the frequency of the digits, the sums, pi itself.
Right. It makes you wonder, is there some underlying mathematical law we haven't figured out yet? Some principle governing all of this?
Or is it all just like a cosmic coincidence?
Yeah.
Just within this one tiny sliver of pi.
It's a question that might never be fully answered.
And maybe that's okay.
Maybe that's the point.
It definitely makes you realize how much more there is to discover, even in something we think we know, like pi.
Absolutely.
Yeah.
That's the beauty of a good deep dive, right? It's not always about the answers.
It's about the journey, the questions, the mystery.
Exactly.
So, to all you deep divers out there, remember, keep asking those questions, keep exploring, keep digging. You never know what you might find.
And if your exploration leads you to any groundbreaking pi discoveries, you know where to find us.
Until next time, happy diving.